Okay, so we're in discussion related to voltage divider circuits, and I told you guys I would film a little bit of proving that this, the way polarities work, and how we can sort of start to identify voltage drops across each of these series connected light bulbs, and if we meter them with respect to each different point, like point E to A or A to B or A to C, we could then come up with some values. So the purpose of this video is to reinforce that in a more visual way. Okay, what I've done is I've drawn out our series circuit that we've done in our learning hub here. We've got two 60 watt bulbs connected in series to a 100 watt bulb and then another 150. I've written those out up top here. Okay, and I've labeled the points E, D, C, B, and A at the end there. And then what we're going to do is we're going to try to figure out what the voltages are, VA to B, VA to C, VA to D, VA to E, etc. Prior to doing that, we need to solve the voltage drops across each light bulb. Okay, so let's get started with that. I'm going to power on here. Okay, I'm going to turn my voltage up. Oops, what's going on here? Yeah, that's right. Okay, I'm just going to verify my voltage output. We're in volts DC. Okay, and I'm going to zoom in a little bit here so that we can maybe capture that. Okay, so my voltage output of my source, if I can get my leads untangled. Here's my negative, here's my positive. We're at 95. We're just going to come up to 100 if we can. Jumping around a little bit here. That's pretty close to 100. Okay. So now, my voltage across the 60 watt bulbs are 38 volts apiece. Actually, no, we're going to call it 40. Looks like we got 41 and 40. We'll call them both 40 volts. Meaning that we've got only 20 more volts to be dropped across our 100 watt and our 150 watt. So this one we've got 15 volts. And this one here, across the 150, we've got 5 volts. Okay, so if we review back on our VA to B, if we've got 5 volts here, then we would anticipate if I put my common, my negative, on my positive potential and my negative on my my positive at more negative, I get a negative 5 volts there. Okay, VA to C, we get a negative 20 volts. VA to D, negative 60. Kind of jumping a bit, 61, 60, 62, and then a negative, A to E. We're a negative 100 volts. Okay, but if I flip my polarities around and have my common from my meter at point E now, the negative, and I go E to A, sorry, my lead's all twisted, E to A, shows me a positive 100. Okay, E to B, $95. E to C, 80. And then obviously E to D is just going to be the 40. Okay? So that's what we're looking at there for our values. All right? So the purpose of that was just to reinforce the fact that our polarities, our reference points within here, the polarity does matter with the way that we apply the meters. In a digital meter, it's just going to come out negative or positive. If it was an analog meter we were using, we'd have some downscale deflection, which could damage the meter at some points. All right? So that's that. Thank you.